Welcome. So in this lesson, we're going to be talking about difference of perfect squares. This is an advanced concept. It's something you'll see in Year 9. Our learning intentions to understand what type of expansion forms a difference of perfect squares, which we refer to as DOPS. So DOPS is just D-O-P-S, difference of perfect squares. And our next learning intention is to be able to expand to form difference of perfect squares. So before we dive into difference of perfect squares, let's remind ourselves about perfect squares, which we saw in our previous lesson. Now, there are two different types of perfect squares. We can have a plus b squared. So in this case, we have a plus b multiplied by a plus b. And if we were to expand that, we end up with something looking like this. Then the other type of perfect square is a minus b squared. So this is when we have a minus b multiplied by a minus b. So this one we have two pluses, this one we have two minuses. If we were to expand this one, we end up with that. Now, in this lesson, we're going to be talking about difference of perfect squares. That's when you have a plus b, then a minus b. So hopefully you can see the difference between a perfect square and then a difference of perfect squares. Now, the name difference of perfect squares comes from what happens when you expand this. If I was to expand this, what ends up happening is this negative AB and this positive AB, they go away because, it's negative AB plus AB, they just go away with each other, which then leaves me with A squared minus B squared. Well, this is a squared number, right? Because it's A squared. And then I'm subtracting from it b squared. So what I'm doing is I'm finding the difference of perfect squares. I'm just subtracting perfect squares, and that's where the name comes from. I always like going through a bit of a visualization. So let's now go through that now. You'll see different types of visualizations. This is just the one I'm using here. So if I asked you to find the area of this shape here, you would say, well, I need to find the width and multiply it by the length. If this right here, if this is x, now I'm saying that this right here is -3 length. So that might be a bit abstract, but in this world, this is going to exist. In the real world, you can't have negative length, but here we can. And what you would end up saying is it's just x plus -3, which is the same as just x minus 3. And then here we have x plus 3. So this whole thing here is just going to be x plus 3. So I have found my width, I have found my length. To find the area now, I'm going to multiply them by each other, like so, like this. Now, it's really important that you're able to recognize that that is difference of perfect squares because I have a plus and a minus there. And it's the same, it's x3, x3. What we're now going to do is we're going to expand it. And you can always expand things the slow way. What I mean by that is going this times this, this times this, this times this, this times this. X times x is x squared. And that would correspond to this right here, this area, which is green because it's positive. Then we'll go x times -3, which is going to be -3x. And that would correspond to here, -3x. So here's -3, and here's x. And I've colored it red because it's negative area. Then the next one would be 3 times x, so it's going to be 3x there. That's positive, it's down here. And then the last one that I have is 3 times -3, which I'm going to write as -3 squared. I could put 9, but for now, let's just leave it like that. So that's right here. Now, hopefully what you can see here immediately is that this -3x and positive 3x are going to go away. And if we think about it in terms of this visualization here, this is the same area as this, but they just have different signs, so they just cancel each other out. So that means what I'm left with is this x squared, then minus 3 squared. Now, hopefully you can see that this right here, this is a square, and I'm subtracting from it another square. So difference of perfect squares. So hopefully you can visualize that as well. And then if we want to finish off this expansion, we would write x squared minus 9. And that's our answer. Now here's the really handy thing and why we've gone through this. If we immediately recognize that what we have is a difference of perfect squares, we don't have to go through this long procedure of expanding it out and gathering like terms. We can just immediately say this is going to be that. So in other words, take x, square it to get x squared, then subtract from it the square of 3, which is 9, and we're done. That's the really important thing of recognizing difference of perfect squares. So if you were given a question like this, expand x plus 2, x minus 2, well, you should immediately recognize that this is difference of perfect squares. So I'm just going to take this term and square it, and then subtract from it this term and square it. So I'm going to get x squared minus 4. That's a lot quicker than the alternative. The alternative way to do it, which does work, is to do it the long way. So I would have to go, I have x plus 2, x minus 2. So I'm just rewriting out the question here. And then from here, what you would have to do is go x times x is x squared, x times negative 2 is negative 2x, and this by this is plus 2x, this by this is minus 4. These cancel out with each other, so I'm left with x squared minus 4. You can appreciate that we get the same answer, yes, but this way is a lot quicker, and that's the way we want to do it. And especially becomes useful when you have things that look a bit funky. So as we come over here now, you should immediately be able to recognize that, hey, it's 3x minus 2y, 3x plus 2y. This is difference of perfect squares. And because we recognize that it's difference of perfect squares, I'm just going to take this, square it, then subtract this and square it. So I'm going to get 3x squared is 9x squared minus 2y squared is 4y squared. And that is our answer. You can appreciate that that's a lot quicker than doing it this way. And then the last one, just to finish it off, again, the first step of doing these things is just recognizing that it's difference of perfect squares, and then just saying I'm going to take the first term, square it, then minus from it the second term, square it. This is going to be 25 minus x squared. And just like that, we have gotten our answer. So the trick with these, when they're asking you to expand, is just to recognize that it's difference of perfect squares and not getting them confused with your perfect squares here. So being able to differentiate these from this, and then you're able to expand super duper quick. Hopefully you found this useful and interesting, and hopefully you enjoy the exercise after this. Bye bye.